Hello geometers and general seekers of truth. In this video we are going to prove a very useful theorem called the vertical angles theorem, and this will be our first proof in geometry, our first formal one at least. Okay. So we want to show that if two angles are verticals with each other, then they are also congruent. Okay? And just like what we've been doing with formal systems, there has to be a starting statement and an ending statement. And the hypothesis is always the given that you started with. So a hypothesis is given. It's the starting statement. Okay? And the conclusion is the finish. So just as the name suggests, the conclusion here should be the ending statement, similar to what we did yesterday. So what I'm going to start out with is using this picture here. You can see that angle 1 and angle 3 are vertical angles. So given that angle 1 and 3 are vertical angles, that's how we're going to start. What we're going to end with is angle 1 must be congruent to angle 3. So that's how every single proof will work. You have a starting statement and then you have an ending statement. Now the wonderful thing about geometry is that there are a great number of rules, lots of properties, postulates, lots of information that we can use. But the challenge of geometry is making sense of all of them and determining when some of them are useful and when some of them are irrelevant. So this being our first proof, what I've already done here is gave you 4 rules here that is going to be very useful and will apply to this problem. So we know that linear pairs are supplementary. Supplementary means that the two angles add up to 180 degrees. The subtraction property and the substitution property. So I'm going to start by using this picture here and having angle 1 and angle 2 be linear pairs, okay? Because that's in fact what they are. So angle 1 and 2 form a linear pair. And we always have to explain why this is true, why every statement is true. And this was given in picture. Okay. Now we also know then if they were linear pairs, then the sum of the two of them would add up to 180 degrees. Okay. So that's really the rule 1 and 2 here. Linear pairs are supplementary, and supplementary, that means they add up to 180 degrees. So I could write both of those down, but I'm just going to state the rule here. So rule 1 and rule 2. Next, you can see here for this very much the same reason as above, 2 and 3 form a linear pair. So angle 3 and angle 2 form a linear pair. And again, this is given in the picture. So just as before, we can say that the measure of angle 3 plus the measure of angle 2 is equal to 180 degrees, and that is the combination of rule 1 and rule 2. Tells us that this must be true. Now if you notice here, this statement 1 plus 2 equals 180, 3 plus 2 equals 180, they're both an expression that's equal to 180, so we can make them equal to each other. In other words, what we're going to do is we're going to take 1 plus 2, angle 1 plus angle 2, and substitute it into 180. Okay? You don't have to annotate yours the same way that I did, but I'm just trying to illustrate that what we're doing here is applying the substitution property, taking 1 and 2 and substituting it in for 180 degrees. So what we have is the measure of angle 3 plus the measure of angle 2 is equal to this substitution, the measure of angle 1 plus the measure of angle 2. And again, we always have to give our reason. In this case, this is rule number 4, or the substitution property. And we're almost done. We almost have angle 1 is congruent to angle 3. So the last step here that we need to apply is, well, if we can just subtract the measure of angle 2 from both sides. Let me get a pen that actually works here. Subtract the measure of angle 2 from the left and subtract the measure of angle 2 from the right. So what we end up with is the measure of angle 3 is equal to the measure of angle 1. And what we're doing here in the last step is applying the subtraction property. Okay. Or rule 3 right here. And there you have it. You completed your first proof. This is proof that two vertical angles are always congruent to each other. And we're also going to give this proof a name just so that we could reuse it later. This is very, very useful. This has a special name. It's called the vertical angles theorem. Okay. And this is useful for us because when we start to use more complicated proofs, we can refer to this theorem as our reasoning to do more complicated work. Okay. So a few things about this proof and proofs in general. They should have a clear start. That's always the hypothesis of the conditional. They should have a clear ending point, which is always the conclusion of the conditional. And every step in between should be easy to follow. Going from one line to the other, it should be clear what you're doing and the reason that allows you to do so, the rule that you're applying in this case. Okay. So proofs are a bit challenging. You watch me do it and I do it right the first time, but that's because I've had a lot of experience doing this. It's okay if you make a lot of mistakes. It's why we do math and pencils. And it's okay if you have to stop and restart, and it's perfectly normal if it takes you more than 1 or 2 tries in order to get to the right solution. Keep working at it, keep persevering. Thank you for watching, and have a wonderful day.